The red car project shows how to control a toy car with Numato Bluetooth device and AltonaLab SCADA software. The car is equipped with many sensors, so the user can see the orientation of the car in space and distance between front object and back object. For all the orientation sensors, I use a mobile phone with Altona Remote Sensors Android application, which sends the sensors information per 1 second through TCP/IP communication to host computer. The orientation sensors are for azimuth angel, which shows the direction of the car, now it gets north direction, pitch angel, and row angel. To measure the distance between front object and back object, I use two sharp distance sensors with analog outputs. They work in range 10 to 80 centimeters, and they are connected to two analog inputs of Numato Bluetooth device. The distance between the car and front object and back object is shown on these two controls. For example, I will show the distance between the car and back object on this control. When the distance between car and object is under half meter, the lamp over the control becomes red. With 4 digital outputs of Numato Bluetooth device, I control the DC motor for forward and back direction and left and right direction. A SCADA diagram has two modes. One of them is manual mode. In this mode we can control the car using a keyboard. Front direction, back direction, front left, back left, front right, back right. In automatic mode, the car starts to move in front direction until the front sensor sends the object. Then the car stops and a SCADA software remembers the current azimuth angel. The car starts to move in back left direction until the difference between a car's azimuth angel and remembered last azimuth angel becomes 90 degrees. If this event never happened, the SCADA diagram will wait 6 seconds and will stop the back left moving. Then a car starts to move again in front direction. Okay, let's start the car in automatic mode. It moves in front direction, stops, back left direction until 90 degrees, starts in front direction, stops, back left direction until 90 degrees, stops, starts in front direction. I will stop the automatic mode. For this project we need an old radio controlled car. We will use only its DC motors, DC motor driver to control the DC motors, Numato Bluetooth device with 8 GPIOs. We will use 4 of its digital outputs to control the DC driver and 2 analog inputs to read the values from distance sensors. The distance sensors work in range 10 to 80 centimeters and have analog outputs, battery and 5-volt voltage regulator. Because the car is very fast, we have to reduce the speed of forward moving DC motor. For this purpose I use a pulse-width modulation with 555 integrated circuit. It is connected to enable signal of the DC motor driver, and I experimentally set the needful filling factor of the impulse. Additionally, we need an old phone with Android operation system with installed Altona remote sensors application, which sends all the information from all the phone sensors to a SCADA application using TCP/IP communication. To assemble all the parts of the car, I use a silicon pistol like that. How everything works. The motor driver controls the two DC motors for forward and back direction and left and right direction. When the enable signal is in high level, the high level of input 3 means forward direction, the high level of input 4 means back direction. The same happens with DC motor for left and right. To control the DC driver, I use IO 2, 3, 4 and 5 from Numato Bluetooth device, and they are set as digital outputs, and IO 0 and 1 they are set as analog inputs to read the values from front and behind distance sensors. The enable signal of the forward-back DC motor is controlled from pulse-width modulation, and this allows to reduce its speed. The SCADA diagram has a few areas. The control area shows all the car sensors: azimuth angle, pitch angle, roll angle, the distance between a car and front object, and the distance between a car and object behind. If the lamp is in red color, this means there is an object in distance below half meter. There are two groups of buttons for manual control the car and to start and stop the automatic mode. The next area is in green color and represents the control of the car. The main block is Numato Bluetooth block, and its 4 digital inputs are connected to digital outputs of Numato device. They are responsible for forward, back, left and right moving of the car. I use the analog inputs of Numato Bluetooth device to measure the values from distance sensors. These values are converted to voltage using expression block. Then the signal is approximated because the relation between a voltage output of the sensors and distance is not linear. This is an approximation table. So the outputs of the block are in centimeters. The additional logic on the left side of the green area allows combined commands to remote car to be sent. For example, forward left, forward right, back left and back right commands. The next area is responsible for automatic mode. It has two inputs from start and stop buttons and inputs from front and back distance sensors. The last green area is orientation module. It reads the information from phone sensor for azimuth angle and controls the car to turn at 80 degrees when it moves at back left direction.